That's fertilizers. Oh, yeah. So I think there's another detail that I forgot. So since you saw that we were doing a galvanic cell, there's another type of cells of electrochemical cells. So it's actually these type of cells. Let me just put this over there. As you can remember from the galvanic cell here, it's actually a voltmeter. So, but in this case, it's a cell. So in a galvanic cell, chemical energy is converted to electrical energy. But in these types of cells, they're electrolytic cells. In electrolytic cells, electrical energy is converted to chemical energy. So in a galvanic cell, their actions, they just occur by themselves. But in this particular case, in order for their actions to occur, they need electricity from the cell, from the cells. I don't know, like if you understand, but if you have a question, you can still ask. So do you understand that part?
Yes, sir.
So I think it's gonna be question 9. I think it's question 8 and 9. So how am I gonna do this? How do I get that whiteboard out? Let me just put this on the side, put that on this side. Yeah, so we're gonna have our question paper on one side, then I'm gonna do everything on the on this side. So here in 8.1, they say when a piece of sodium metal is added to water in a test tube, hydrogen gas is released. When the phenolphthalein, man, I hate this name. Phenolphthalein, whatever, indicator is added to the test tube, the solution turns pink. So they like describe the term reduction in terms of electron transfer. In terms of electron transfer, reduction is when an ion gains electrons. So I think that's a simple enough concept. So they say in the sodium metal is added into a test tube of water. Then they're gonna ask us for the reduction half reaction. So for the reduction half reaction, you just simply go to your table, which you have here, and you're gonna look for sodium. Then we have sodium down here. So for your reduction half reaction, you just have to write this equation. let's go back up. So they say write the balanced equation for the reaction that takes place. So now, since you found your reduction half reaction, you just go back to your table. And since they told us that sodium is added into water, what can I use to draw here? Come on, note the pencil real quick. Yeah. So that's gonna be an A and A plus an electron. It's gonna give you an A. Then you're gonna look for water. Since they said so, the sodium is added to water. So as you can see here, we have water. So we're also gonna use that. What's that thing? So we're gonna have 2H2O plus an electron plus 2 electrons is gonna give you H2 gas plus 2 hydroxyl ions. So now, since they want the balanced equation, this is your equation 1, and this is your second equation. Since they want the balanced equation, you're gonna say 1 plus 2. Where's that one? But I just noticed something. They say a piece of sodium metal is added. So that means sodium is actually gonna get oxidized. So that action is gonna be something like this. Instead of it going forward, it's gonna be backward. Do you understand that? Because it's gonna go from a solid state to an aqueous state. So the actual equation, let's say it's 1 and 2. So you're gonna have Na plus 2H2O plus 2 electrons, which is gonna give you Na plus, so the sodium ions, Na plus plus H2 plus 2OH minus plus an electron. So do you understand so far?
Yes, sir.
So the first thing you need to check is whether the mass is balanced. So to check if the mass is balanced, you're gonna check the amount of atoms on each side. So you have one Na, you have one Na, 4 hydrogen, 4 hydrogen, 2 oxygen, and 2 oxygen. So now what's next is that you're gonna check the charge. So on this side, since there's only one electron, the charge is -2. But in this side, there's +1, 2 times -1, that's gonna be 1 minus 2 minus 1. So this and these are gonna cancel out. Then you're gonna be left with -2 on that side and -2 on this side. So your equation is balanced both in mass and both in charge. So I think that's gonna be your answer for question 8.1.3. So now the next question they ask, why does the solution turn pink? Honestly, I haven't done this experiment before, so I can't tell you why the solution turned pink. I just hope but if you guys do the experiment, they'll explain to you why it turned pink. So is that fine?
Yes, sir.
So we solve for the final equation. Now we're gonna go to the next question. Where they say, when a piece of copper is added to water in a chest tube, no reaction is observed. So they say refer to the relative strength of the reducing agents to explain why no reaction is observed. So let me just click on this. From the table, you can see that water. Sorry. Hello. Sorry about that, but from here you can see that for sodium, the potential is 0 is 0.71, meaning sodium, I mean, sodium can be reduced. Sodium can reduce water. That means sodium is able to donate electrons to the water molecules. That's why a reaction occurs. But with copper cannot reduce water. It can only oxidize the water, meaning that copper is not gonna donate electrons to the water. So that's why no reaction is gonna occur. I hope that makes sense.
It makes sense, sir.
Okay. So I think this is gonna be our last question. So they say we have a cell notation. Let me just show you something real quick. So when they give you a cell notation like PB solid, uh, PB 2 plus aqueous. That shows you that this metal, it's gonna be oxidized because it's gonna lose electrons. So it's gonna be something like PB. It's gonna give you 2 plus plus 2 electrons. So this metal is the one that's gonna be oxidized, meaning it's our anode. Then this is a cell with Fe3 plus Fe2 plus. It's gonna be a solid. I'm sorry. Do you know the names of these metals? I'm sorry. Let me just search their names very quickly. PP. So that's lead. I think it's lead and platinum. It's lead and platinum. So basically, this line means that the the metal is gonna get oxidized, or is changing from this to this. So that's why, like, they asked what's the signal line in the send notation above represent. Then they're gonna ask you for the energy conversion that's gonna take place in the cell. Like the energy conversion that's gonna be chemical energy to electrical energy. Then they say state the initial EMF of the cell under standard condition. So the initial EMF, they basically want the electric potential of the cell. So that means is equal to E cathode minus so from this we know that lead is gonna be oxidized. So that means lead is our anode. And from this information, iron is turned into platinum. So platinum is gonna be reduced, making platinum our cathode. So all we have to do is go back to the table. So they usually give you an extra mark for stating, for showing that this is not reduced, it's gonna be oxidized, and for changing the sign in front of the reaction. So where's lead? Lead. So down here we have lead, but this is the reduction reaction. So we're gonna have to change it to an oxidation reaction. So that means it's gonna give us 0.13. So we're gonna have to look for platinum now. Where's platinum? So for platinum, that's gonna be 1.20. So since we know our values, the EMF that's gonna be 1.20 minus into 0.13. Oh, that's gonna give me 1.07 volts. So yeah, I think that's it. David.